All right, this is worksheet number 2. I'm going to do problems 6, 8, and 10. The first thing I want to go over are the 5 things we need to find for number 6. We need to write the equations for vertical asymptotes, horizontal asymptotes, the whole or holes, state the domain and range, and graph the function, including the discontinuities. So the first thing I always do is go actually do part D and do the domain. So for number 6, right now you should be able to see that for part D that the domain is all x's such that x cannot be positive 3. And again, we get that from the bottom. Whatever makes the bottom 0 is a domain restriction. Okay. Next thing I'm going to do is I'm going to factor the top. And when I do that, I get x plus 5 and x minus 3. And sure enough, we have two things canceling out on top. This means that the x minus 3 represents a whole, not a vertical asymptote. So for part A, what are the vertical asymptotes for this problem? There are none. There's nothing left over on the bottom. There's only one thing on the bottom, and it's a whole. Now let's look for horizontal asymptotes. The degree on top is 2. The degree on bottom is 1. When the degree on top is higher than the degree on bottom, there is no horizontal asymptote. So this one has no vertical or horizontal asymptote. And finally, we need to find the coordinates of the whole. Well, we know that the x-coordinate is 3. We get that from the domain restriction and the fact that that was canceled out. Let's rewrite this in simplified form. The simplified form for this function or equation is x plus 5. So when you want to find the y-coordinate of the whole, you just take the 3 and plug it into here. So we get 3 plus 5, which is 8. So that means that the y-coordinate of the whole is 8. So I have a whole at 3, 8. All right, so we got A, B, C, D. We do not have the range yet, but I will do the range at the end here. And finally, we need to graph this. The only thing we know from this, from all this information, is that there is a hole right here. Okay. Now, when we go to graph, move that over a little bit. When we go to graph this, actually, oh, I'm on. Well, that's fine. On the top, we had x squared plus 2x minus 15. And then on the bottom, we had the x minus 3. Okay, when we graph that, unfortunately, you have to look to the right here. It looks like a straight linear line, or a line, because the top and the bottom cancel, and we're left with just x plus 5. So the graph for this will just look something like this. But there's a hole there, so notice how there's no vertical or horizontal asymptotes. The end behavior is just going off forever. The range restriction, though, is there's no y value at this hole, so y cannot be 8. So that is number 6 on worksheet 2. Let's do number 8. Write a rational function. I need to write a function, do not forget the f of x, that has a vertical asymptote of x equals -4 and a horizontal asymptote of y equals 3. Well, let's make a fraction here. Vertical asymptote has to come from our domain restriction. It comes from being on the bottom. So I'm going to put an x plus 4 down here. Okay, we have nothing else. Well, we could maybe put something else later, but we have that, and then all we need is a horizontal asymptote of y equals 3. In order to get a horizontal asymptote other than y equals 0, it's the ratio of the lead coefficients. So I'm going to put a 3 on here, and I'll just leave that as a 1. You don't even have to put a number there if you didn't want to. But the only way that that could happen is if the x's on top and bottom balance. So since we have a degree of a power of 1 on the bottom, we need something on the top to balance that. So I'm just going to put x. And there is a rational function that has a vertical asymptote at x equals -4 and a horizontal asymptote at y equals 3. You could also have done anything else on top, as long as you put, well, except for x plus 4. You don't want it to cancel out. You could have put x plus 2 on top and an x plus 4 on the bottom. You could have also, I'll just do another one, x minus 3 on top over x plus 4. All these are acceptable answers for this problem. Make sure, though, you have the f of x. It says write a function. It means you need an f of x and an equal sign. Don't just write the expression down. All right, and last one, we are going to do number 10. Okay, this one's a good problem because it just talks about the average cost per hour. Okay, well, think about it. If I pay a $120 membership and I use it once, 1 hour, I pay $125, I'm spending $125. And that's per hour too. That's not getting my money's worth for this membership. The better that, the more time I spend, my average cost goes down. You're starting to get your money's worth more. So let's write a cost function first. Well, normally the cost would be $120 plus $5 per hour, 5t. But it says write a model that represents the average cost. So the average cost, well, average you divide by the number of units. Here we're doing per hour. So my actual equation becomes 120 over t plus 5. Okay, so now this looks like a problem that we've been seeing before. I have a vertical asymptote when t is 0, and of course we probably want to look only at, since it's a word problem, I don't want negative time, so I'm going to be looking mostly just here. So as t gets bigger, the average cost goes down. So let's say the average cost is, well, it says what is the horizontal asymptote and what does it represent? In this case, since this goes to 0, the horizontal asymptote is 5. The cost is $5, the average cost. 1, 2, 3, 4, 5. So here's my horizontal asymptote, and of course we had our vertical here, but that doesn't matter. And when you graph this on your calculator, you'll see that it looks something like this. As time goes on, the average cost gets closer and closer to $5, which makes sense. If I pay $120 as my fixed cost and then spend 100 hours on the racquetball court, that's what, $620 divided by 100 hours is I'm averaging about $6.20 per hour. The more I use it, the more my average cost goes down. However, we can never ever reach this $5. The $5 is the average cost that it will never hit. And the reason why it will never hit it is because of you have this initial $120. If it wasn't there and you just were paying $5 per hour, it would be an average cost of $5 per hour. But you have that extra $120. So that's why the average cost function looks like that. All right, and that is all.